Hello veterans, welcome to my new channel. Please stay and watch the video as a help to my hard work and sincere dedication. I have created this video for entertainment purposes only. For over 100 years, one military weapon has survived every attempt to replace it. The United States Armed Forces have repeatedly searched for a successor to their famous .50 caliber machine gun. New prototypes were built. Defense companies presented advanced concepts. Entire programs consumed enormous budgets in pursuit of a modern replacement for a weapon whose origins traced back to the era of trench warfare. Yet every effort reached the same conclusion. No contender could provide enough improvement to justify removing the old design from service. Again and again, military evaluators discovered that the aging machine gun still performed its mission exceptionally well. Eventually, a realization emerged that few had expected. The problem was not that the weapon was outdated. The problem was that nobody had managed to build something meaningfully better. So rather than replacing it, the military chose a different path. The design received only modest improvements, while the core mechanism remained largely untouched. As a result, a machine gun conceived more than a century ago continues to serve on some of the most advanced combat vehicles and weapons platforms on Earth. Its story begins during the First World War. As the conflict dragged on, battlefields started changing in ways military planners had never anticipated. Armor began appearing with increasing frequency. Aircraft gained protective plates around pilots and critical systems. Tanks rolled onto the battlefield as an entirely new category of weapon. Suddenly, the rifle-caliber machine guns that had dominated combat were no longer guaranteed to penetrate their targets. American military leaders noticed the problem. At the time, there was a significant gap between ordinary machine guns and artillery pieces. Infantry weapons lacked the power needed against emerging armored threats, while artillery was often excessive for the task. General John Pershing wanted a solution. He directed the Army's ordnance specialists to develop a heavy machine gun capable of firing a projectile at least half an inch in diameter. The new weapon needed high velocity, substantial armor-piercing capability, and enough flexibility to engage a wide variety of targets. Meeting those requirements would prove difficult. The development effort passed through numerous experiments and unsuccessful concepts before eventually reaching one of the most influential firearms designers in history, John Moses Browning. Rather than inventing an entirely new system from scratch, Browning built upon technology that was already proven. His team began with the .30-06 cartridge and explored ways to increase its size and performance. Throughout development, they examined captured German ammunition, including the powerful 13-32mm cartridge used in anti-tank rifles. That round provided valuable lessons. Its performance closely matched many of the characteristics Pershing had originally requested, giving Browning's engineers useful benchmarks as they refined their own design. After numerous modifications and redesigns, the team arrived at a cartridge that would become legendary in military history. The result was the .50 Browning machine gun cartridge, commonly known as the .50 BMG, or 12.7 meters. Creating the ammunition, however, solved only half the problem. A weapon capable of firing it still had to be built. Browning's answer was to scale up his successful M19-917 machine gun. On paper, the concept seemed straightforward. In practice, it presented serious challenges. The new cartridge produced roughly 4 times the energy of the .30-06 round. That increase placed enormous stress on every component. Receivers, bolts, locking mechanisms, and internal parts all required reinforcement. Simply enlarging existing components was not enough. Engineers repeatedly revised and tested the design as they struggled to create a machine gun capable of surviving such powerful ammunition. Progress was slow. Then events overtook the project. On the same day one of the prototypes was being demonstrated, the First World War came to an end. The conflict that had inspired the weapon's creation was suddenly over. Many military projects would have ended there. This one did not. Development continued through the post-war years until engineers produced the M1921. Unfortunately, the machine gun entered service after the fighting had ended, leaving the military uncertain about how it should be employed. The M1921 was a formidable weapon, but it came with serious drawbacks. It relied on water cooling and weighed approximately 80 pounds before any supporting equipment was added. Once crews included the tripod, ammunition, cooling system, and accessories, the complete setup exceeded 120 pounds. For infantry units, that was a major burden. The weapon's size pushed it toward specialized roles, particularly anti-aircraft defense. Additional limitations complicated matters. Ammunition could only be fed from one side, creating difficulties when installing the gun in aircraft and armored vehicles. Although its firing rate was respectable, it offered no dramatic advantage in that regard, while its ammunition remained considerably heavier and more expensive than standard machine gun rounds. Despite these issues, some military organizations recognized its potential. The U.S. Navy adopted limited numbers for shipboard anti-aircraft use, ensuring the project remained alive. Then another major event threatened its future. In 1926, John Browning died. Without the man who had designed it, the weapon's long-term prospects became uncertain. It could easily have faded into obscurity. Instead, another engineer took up the challenge. Dr. Samuel Green inherited the project and began addressing the weaknesses that still remained. One of his most important insights was deceptively simple. The military did not require a single heavy machine gun. It needed a system adaptable enough to serve many different roles. Green redesigned the receiver so ammunition could feed from either side. By altering internal components, armorers could configure the weapon for a variety of installations, greatly improving its usefulness in aircraft and vehicles. Further refinements followed. Eventually, Green's team created a universal receiver capable of supporting multiple configurations. Depending on the barrel and external components attached, the same basic weapon could serve as a water-cooled gun, an air-cooled gun, a vehicle weapon, an anti-aircraft platform, or an aircraft machine gun. The flexibility was unprecedented. From those efforts emerged a new designation that would become famous around the world. The Browning M2 had arrived. The new Browning design quickly proved far more adaptable than its predecessors, but its true transformation was still ahead. As military aviation expanded through the 1930s, older rifle-caliber machine guns began to lose effectiveness. Faster, more durable aircraft demanded heavier firepower, and the .50 caliber round gradually became the preferred solution for air combat. Engineers developed lighter aircraft-focused versions of the M2 to meet these needs. These variants used thinner barrels and reduced overall weight to suit the strict limits of aviation. In the air, overheating was less of a concern, since high-speed airflow cooled the weapon naturally, and pilots typically fired in short bursts rather than sustained streams. In this environment, firing rates could be pushed significantly higher, with some aircraft-mounted versions exceeding 850 rounds per minute. The result was a dense, concentrated volume of fire that proved highly effective against enemy planes. However, what worked well in the sky did not translate smoothly to ground combat. When the same air-cooled designs were used in sustained firing roles, they overheated quickly. Continuous ground engagements placed far greater thermal stress on the weapon, leading to wear and potential damage. To solve this, engineers developed a reinforced version known as the heavy barrel configuration. This upgraded design increased barrel thickness and length, allowing it to absorb heat more effectively during prolonged use. The added mass made a significant difference in durability and sustained performance. The trade-off, however, was weight. The ground version now weighed in the range of 80+ pounds, still far from ideal for mobile infantry use, but far more practical than earlier water-cooled systems that required additional equipment. This iteration became the standard configuration for ground forces, marking a turning point in the weapon's long evolution. Just as this refined version was maturing, global events once again reshaped its purpose. With rising tensions in Europe and the Pacific during the late 1930s, production accelerated rapidly. The weapon was deployed across multiple platforms, from aircraft to ships to armored vehicles, as nations prepared for another large-scale conflict. When war finally erupted after the attack on Pearl Harbor, the Browning machine gun was already deeply embedded in American military forces. It was present in naval defenses across the Pacific, mounted in aircraft, and installed on a wide range of vehicles. Within days of the attack, it found itself engaged in full-scale combat across multiple theaters. Shortly afterward, the United States entered the global war, fully following declarations from other Axis powers. The weapon's role expanded immediately. In the air war, it became one of the defining features of American fighter aircraft. Many designs relied heavily on multiple .50 caliber guns mounted in their wings, creating overwhelming bursts of firepower during dogfights. Some fighters carried 6 of these machine guns, arranged in symmetrical wing-mounted pairs. Others pushed the concept further, mounting even greater numbers to maximize destructive output. One particularly famous example carried 8 of these weapons, producing an intense wall of fire capable of shredding enemy aircraft. Another approach placed the guns directly in the nose of the aircraft, allowing all rounds to converge on a single point with greater accuracy and concentration of force. Bomber aircraft depended on the same system for survival. Defensive turrets equipped with multiple heavy machine guns became standard across Allied bombers. These positions were essential for protection against enemy fighters attempting to intercept formations during long missions. One of the most heavily armed bombers of the war carried more than a dozen of these weapons distributed throughout its airframe, creating overlapping fields of defensive fire. In the Pacific, aircraft designers pushed the concept even further, modifying medium bombers into aggressive low-altitude attack platforms. These aircraft were fitted with extraordinary numbers of heavy machine guns, sometimes reaching into the high teens. At low altitude, they could sweep across enemy positions, saturating entire areas with suppressive fire. Defensive positions, exposed crews, and light structures were quickly overwhelmed before any meaningful resistance could form. Once enemy defenses were neutralized, follow-up attacks by additional aircraft could complete the strike with far less resistance. On the ground, the weapon became equally widespread. Any vehicle capable of supporting it was fitted with the heavy machine gun in some form. Tanks, half-tracks, armored cars, trucks, and even jeeps frequently carried it as part of their standard equipment. In armored warfare, it was commonly mounted on turret tops, originally intended for defense against aircraft, but quickly adopted for broader use. Tank crews often found themselves operating the weapon from exposed positions, sacrificing protection for the ability to engage threats above and around them. Despite the risk, the advantage was undeniable. The weapon provided a rapid response against both ground and air targets, something few other systems could match at the time. Its presence alone often discouraged low-altitude enemy air attacks. Beyond aircraft and vehicles, the weapon demonstrated remarkable destructive capability against a wide range of battlefield targets. Light fortifications, sandbag positions, wooden structures, and lightly armored vehicles were all vulnerable. Even heavier targets could be damaged given enough sustained fire and favorable angles of impact. German armored forces learned to respect its reach, particularly against thinner side armor on certain vehicles. Perhaps most importantly, the weapon excelled at long-range engagement. Mounted on heavy tripod systems, it could deliver effective fire at distances that exceeded 2,000 yards. At those ranges, its rounds retained enough energy to remain lethal and accurate. While other machine guns could theoretically match such distances, their effectiveness dropped off far more quickly, giving the Browning a distinct advantage in extended firefights. This made it especially valuable in open terrain, where long sightlines allowed it to dominate enemy movement and suppress positions before they could respond effectively. Its psychological impact was just as significant as its physical power. Opposing troops quickly learned to fear its reach and consistency, often altering movement patterns and tactics to avoid exposure. In many situations, the weapon was used not just to engage known targets, but to probe uncertain areas. Short bursts were fired into suspicious terrain, forcing hidden enemies to reveal themselves or risk destruction. This practice reduced the danger of ambushes and allowed advancing forces to test areas without committing larger resources. Another specialized application emerged in the form of multi-barrel anti-aircraft systems. By combining several of these machine guns into a single powered mount, engineers created a platform capable of delivering an overwhelming volume of fire. Originally designed to counter aircraft, these systems later found new life against ground targets when air superiority reduced the threat from enemy planes. Their concentrated firepower made them extremely effective in suppressing infantry positions and clearing light vehicles. As the war progressed, the weapon evolved into a family of configurations rather than a single design, adapting to the needs of each branch of service. By the end of the conflict, it had become one of the most widely produced and universally recognized weapons in the Allied arsenal. Its presence felt across every major battlefield, on land, sea, and air. Even after the Second World War ended, the weapon's story did not slow down. Instead, it entered a new era shaped by rapidly changing aviation technology and shifting battlefield demands. Jet engines replaced piston power. Aircraft became faster, climbed higher, and carried far more destructive payloads. In this new environment, weapons designed during the earlier war were forced to adapt or disappear. The .50 caliber system was pushed into a difficult position. While it had proven devastating during World War II, newer aircraft designs increasingly favored larger caliber autocannons, firing explosive shells. These weapons delivered far greater single-hit damage, especially against fast-moving jet targets. To remain relevant, the Browning system was pushed into higher performance variants for aircraft use. One such development dramatically increased its rate of fire, exceeding 1,000 rounds per minute in some configurations. The goal was straightforward: compensate for lower per-shot power by increasing volume of fire. For a short period, this approach remained viable in early jet combat. Then the Korean War exposed its limits. Against MiG-15 fighters, American pilots discovered that .50 caliber rounds often failed to produce immediate, decisive destruction. High-speed engagements left little margin for partial damage. Even multiple hits sometimes did not guarantee a kill before the target escaped or returned fire. This reality gradually pushed air forces toward 20 mm and eventually 30 mm class weapons, including rotary cannon systems capable of overwhelming destructive output. As a result, the Browning's role in fighter aircraft steadily declined. Even so, it did not vanish completely from aviation. Large strategic bombers retained modified versions of the system for defensive use. One of the most famous examples was the tail turret of the B-52 Stratofortress, which continued to rely on Browning-derived guns controlled by radar-guided fire systems. These weapons remained relevant long after fighters had abandoned them. During the Vietnam War, one of the last confirmed air-to-air kills by a bomber gunner occurred when a B-52 tail position engaged and destroyed an attacking MiG-21. A second similar engagement reportedly followed shortly afterward, marking the final chapter of bomber-gunner victories in aerial combat. From that point on, the role effectively ended. On the ground, however, the weapon's importance remained unchanged. Vietnam's terrain created conditions where heavy, sustained firepower was still essential. Dense jungle, hidden ambush points, and unpredictable engagement distances made it difficult to replace established systems. Although newer general-purpose machine guns like the M60 took over many infantry roles, the heavy .50 caliber system remained unmatched, when maximum range and penetration were required. It continued serving across a wide variety of platforms: armored vehicles, naval craft, helicopters, and ground emplacements. In convoy operations, its role became especially prominent. Supply routes were frequently targeted, forcing military units to heavily arm transport columns. Standard cargo trucks were converted into improvised fighting platforms, reinforced with armor plating and equipped with multiple heavy weapons. These modified vehicles became known as gun trucks. Some carried multiple heavy machine guns, including quadruple mounting systems inherited from earlier conflicts. When ambushed, these convoys could unleash overwhelming defensive firepower in response. The effect was often decisive, transforming vulnerable supply lines into heavily defended mobile fortresses. One of the most unusual uses of the weapon also emerged during this conflict. Marine sniper Carlos Hathcock demonstrated that the system could be repurposed for extreme long-range precision fire. By mounting a scope onto a tripod-supported heavy machine gun and carefully calibrating it, he effectively transformed it into a massive precision instrument. In a remarkable engagement, he successfully struck an enemy target at an extraordinary distance of roughly 2,500 yards. The achievement became one of the most famous long-range kills in military history and stood as a record for decades. This event also influenced future weapons development. The idea that large-caliber rounds could be used for precision long-range engagements contributed to the rise of dedicated anti-materiel sniper rifles. Designs such as those developed by Ronnie Barrett built directly on the potential demonstrated during this era, turning the 50 BMG cartridge into a cornerstone of modern long-range shooting. Meanwhile, ammunition itself continued to evolve. Beyond standard ball and tracer rounds, specialized variants expanded the cartridge's versatility. Armor-piercing, incendiary, and combined effect rounds became common, each designed for specific battlefield roles. Among the most advanced was a multi-purpose design capable of combining penetration, incendiary effects, and explosive fragmentation within a single projectile. These developments extended the cartridge's effectiveness across a wide range of targets, from vehicles to aircraft to fortified positions. Despite all these advancements in ammunition and optics, the weapon's core mechanical design remained largely unchanged. One long-standing issue persisted through decades of service: the manual adjustment of headspace and timing. Because of manufacturing tolerances in earlier production eras, operators had to carefully calibrate each barrel to ensure safe and reliable function. Headspace determined the precise spacing between bolt and cartridge, while timing ensured the firing sequence occurred only after full lockup. If these settings were incorrect, the consequences could range from malfunctions to catastrophic failures. For decades, crews relied on gauges, experience, and careful adjustment to manage this process, especially during barrel changes in combat conditions. Although effective, the system required skill and attention at exactly the moments when stress was highest. Eventually, this long-standing limitation was addressed with the introduction of an improved variant. The updated design eliminated the need for manual adjustment by introducing fixed headspace geometry, made possible by advances in manufacturing precision. This change significantly simplified operation and reduced the likelihood of user error. Additional improvements included a redesigned flash suppressor, which dramatically reduced visible muzzle flash and improved concealment during night operations. Despite these refinements, the fundamental architecture of the weapon remained intact. The lineage stretching back to its earliest designs was still clearly present. In modern service, the system has taken on an entirely new role. Mounted on remote weapon stations, it can now be operated from inside armored vehicles using electronic controls. Integration with laser rangefinders, thermal optics, stabilization systems, and ballistic computers has transformed it into a digitally assisted battlefield tool. What once required manual handling in exposed positions can now be controlled with precision from protected interiors. Yet even in this highly advanced form, the underlying mechanism remains recognizable. After more than a century of continuous service, countless modernization attempts, and repeated efforts to replace it, the conclusion remains unchanged. The system has not been retired. Instead, it has adapted to every generation of warfare it has encountered, continuing to function in roles that newer designs still struggle to fully replace. Thanks for watching and staying till the end. You are appreciated dearly. Please subscribe and share it to your friends.